this is Unit 5, Lesson 5, Video 1. This is the last video of the unit. We're going to talk about linear programming. And so this is a kind of a long process. So we'll get through one whole example in the video, and then that's what you'll want to model when you're doing the homework and the test. Okay. So linear programming is about maximizing profit or minimizing cost. So let's look at this problem. The area of a parking lot is 600 square meters. A car requires 6 square meters and a bus requires 30 square meters of space. The attendant can handle no more than 60 vehicles. If a car is charged $250 and a bus $750, how many of each should be accepted to maximize income? Income is the same thing as profit. Okay, so just like with other word problems, we can tell what our variables need to be by the question. So how many of each should be accepted? So each what? We're talking about type of car or type of vehicle. So let's say that X equals the cars and Y equals the number of buses. Okay. Write a profit or cost equation. This is also called the objective function. All right, so the profit, and this is profit because we're talking about income. So this is where we put the numbers that deal with profit. Let's do this in red. Okay. So the profit's going to come from what they're charged. So this $250 for a car and $750 for a bus. So that's $250X plus $750Y. Okay, so just on homework and stuff, you might not be given this layout, but this is the order that you want to follow. You want to start with defining your variables. Then you want to write your objective function. Now we're going to write our inequalities. These are also called constraints. So these are the restrictions that we have. So first of all, there's 4 of them. The easy ones, the given ones, are that you can't have a negative number of cars and you can't have a negative number of buses. So that's greater than or equal to 0 and greater than or equal to 0. So let me make a note. You can't have negative number. Okay? And then my other 2 come from the problem. So the parking lot has 600 square meters, and then a car requires 6 square meters and a bus requires 30 square meters. So I have to put everything together. So I have a restriction on the amount of space. Okay? So I need to put that 6x plus 30y, and it's 600 square meters, so I can't go above 600 square meters. So I need this to be less than or equal to 600. Then I also have the attendant can handle no more than 60 vehicles. So my total number of vehicles and remember, when we have a total number of something, that's just x plus y. And less than or equal to, because you can't handle any more than 60. Okay, so that was the hard part here, is writing those constraints. Our next step then is to graph the constraints. So we're graphing the constraints. So your first 2 constraints, the x is greater than or equal to 0 and y is greater than or equal to 0, are just your axes. So all that tells you is that we only want to look in the first quadrant. We don't care about negatives, so we're only looking in the first quadrant of our graph. So we don't really have to graph those. Note that the scale in the x's and y's should go by tens. So I'm going to make a note here that that's 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'll just do this to help. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm also going to label my axes. So X was talking about cars, and Y was talking about buses. Okay. So my other two inequalities, let me write them down here. I have 6x plus 30y is less than or equal to 600. And then I have that x plus y is less than or equal to 60. Okay, so we are going to use x and y intercepts to graph these. I don't have any negatives, any subtraction here, so I don't have to worry about switching my inequality sign. That's really the reason why we put it in slope-intercept form. And so I'm going to be able to say that the less than or equal to, even though it's in standard form, that's still going to be meaning to shade below. Okay, so I will note about the x is greater than or equal to 0 and y is greater than or equal to 0. So that means that this is where we're looking in the first quadrant, so that's where we would shade. We're not going to shade past these axes. Okay, so back to this one. If I want to find my x-intercept, then I cover up y. So 6x, and I'm just using equals for now to find the intercepts. So divide by 6, x equals 100. So I have the x-intercept of 100, 0. And then y-intercept you cover up x, so 30y equals 600. Okay, so we get 20. So 0, 20. All right, so this line is 100, 0, and 0, 20. So I'm going to draw that in, and that'll be a solid line. Okay, and I want to shade below. Okay. Now let me look at this line. X plus y is less than or equal to 60. So if I cover up, I get x equals 60. So my x-intercept is 60, 0. And my y-intercept is 0, 60. Okay. This is also going to be a solid line. Okay. So I'm shading below this one again, too. Okay. So I'm looking for all the overlapping. The whole overlapping is this region here. Okay, so it's important to note to see the region. All right, so this has 4 corners. It has 4 points. I have here, 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 and here. Okay, so the first corner point is 0, 0. And then this corner point here is 0, 20. This corner point here is 60, 0. This one here looks like it's going to be 50, 10. But I don't know that for sure. So I have to make sure that that's the right corner point. So what I'm going to do is that this corner point comes from these 2 lines that I graphed here in the blue and the red. I need to solve that system. So I'm going to write that as an equation. So I'm just writing them as equations. Okay. So this is something separate here. We're checking that corner point, as that really is. So to solve this, then I have to multiply by -6. Okay, and then I'm going to add down. Let me cross that one off. So that's 24y less than or equal to 600 plus -360 is 240. Divide by 24, and we get 10. And we actually, like I said, can just use equal signs. That's what we should be doing here. And then if you plug this in, you'll get x equals 50. Okay, so we did verify that this really was the corner. That's really where they intersected. Okay, so to answer the question then, we take our corner points, so those were 0, 0, 0, 20, 60, 0, and 50, 10. And we plug those back into that profit equation. So remember that profit equation was 250x plus 750y. Alright, so I'm plugging these in for the x and y. So obviously if I plug in 0, I get 0. Okay, let's plug in the next one. So 250 times 0 plus 750 times 20 is 150. And then 250 times 60 plus 750 times 0 is 150. Okay, and then 250 times 50 plus 750 times 10 is 200. Okay, so the corner point that would give them the most profit would be this 50, 10. And it's not always this one where they intersect in the middle. It could be any of the other ones. So it's this one because 200 is the biggest amount. Okay, so to write our final statement is, it says how many of each, the question says how many of each should be accepted. So, let me go back and so we can write that. Okay, so they should accept 50 cars and 10 buses to maximize profit, or as they say, income. Okay. Okay, so that is the final answer. So you'll have to go through all the steps. I know it seems long, and they are long problems, but just take it step by step. Let me know if you have any questions. And now you're ready to do Unit 5, Assignment 9.